backward, turn left and right, calculate the distance on the right direction and on the left, and then turns appropriately to which are the big, the smallest.
The small,
I mean, not the bigger, the bigger.
so it'll go through the bigger one. You always go through the big one. Okay. All right, that's good. Well, I'm excited to see it work.
We hope it'll work. Avoiding obstacle avoiding robot car. We used a motor servo, supersonic sensor, a breadboard, Arduino Uno. We also bought a L293D motor shield for controlling the left and right movement. We have one 9-volt battery and one, I don't know how this is called, but yeah, a battery set of 4 small batteries. So how it does is it moves for robot structure. Yeah, that's abilities. Yeah, so how it works is, say there's no obstacles, it goes for 250 centimeters. But if there's an obstacle before the 250 centimeters, it turns left and right, check the distance of the nearer obstacle, just like the preview robot does, and it turns to the obstacle that is the most far away. I don't know if that makes sense, but yeah, and that's pretty much. Oh, before when it senses an obstacle, it goes backward, and it turns left and right. And we incorporated a light that turns on when it sees obstacles too. We wanted to put a buzzer and all this, but the one problem with the motor shield is that after installation, you only get one digital input-output port left. We did it last night. It was we were tired. It was at 5 a.m. But when
engineering works the best, here's an idea.
Yes, but we have is because the sensor doesn't cover full one piece. Sometimes the obstacle is right on the edge.
So the reason I asked you to use the servo motor.
What?
The reason I asked you to use a servo motor is to cover the 180 degrees.
But we tried to rotate at 180, but
Can you put it like so it goes like it's going directly into the front of the box?
I think the wheel is about.
our first goal is to make a port placement card. So we have to make a voice, and we have to make a light.
Siren and lights. We decided our concept is police car. Yeah, so we made the lights and siren.
Is there a reason you decided not to mount those sensors somehow?
Because the breadboard was too small.
Well, that was the only reason.
How about
What is the light follower?
I like the LED lights there. That's good. And you got the link.
Three, sorry, 2,
Go.
1. I think right wheel where is right wheel. So
following something?
yeah. Oh, right wheel wire.
One of the wheels is already done. It's the same problem that we had with the motor. One is not working.
It worked an hour ago, but it doesn't work right now.
So you made a robot that will only go to the right.
But that's
one
good.
wing is dead.
Yeah, one minute.
It's dead. It's not moving at all.
Thank you. In the computer, you can see the number. It's separate.
Because the policeman sometimes cross the right.
Yeah.
They got some good things in there. You should feel very proud of it.
We soldered in the ceramic capacitor on each motor to reduce the noise.
And then we put the batteries in parallel because series couldn't find
So-
some stuff.
So we have used total 3 packs of battery, but it's connected in parallel. So the output is 6 volts. And then
How about the sensors?
we're using a single
Ultrasonic
sensor.
sensor.
and one servo motor.
And
So-
how about the driver? Are you using drivers or H-bridge?
Yes. Also, yeah, we use the L293D. So that's the H bridge for pairing of. So it gives the input and output to the motor. Yes.
How many ICs have you used?
We use two.
Two. Fine.
So we have a Bluetooth module here. So that lets us to control the robot manually with our smartphones. So while it's driving in an autonomous mode, we can switch back it to the manual mode and then control it manually. While the robot is in autonomous mode, it can be switched back to the manual mode, which can be then controlled by the smartphone. With a press of the start button, the robot stops its mode, autonomous mode, and then it can be controlled by a smartphone. Which, if I press the go forward button here, robot goes forward, backwards, turns left, turns right. And then it stops with the brake button here. And then it can be recovered to the autonomous mode again with a select button here. And the robot is now again in the autonomous mode.